Sorry folks, I was out taking the dog for a walk. I'm a little late today. Thought I'd go over with you, get the protective gear off of course. Thought I'd go over with you some of the work from intermediate algebra that might have been giving you some trouble. I notice people are having a little bit of difficulty with page 396, problems 11 through 18. And so we're going to focus in on those today. Got a couple examples to work with you. And we'll get started in just a second here. Just got to get the last couple details here done. All right. Math dog had a good walk. And we're looking pretty good now. Come on over. What do you think about long division, Math dog? Yeah, it can be kind of rough, can't it? Especially with rational expressions. Okay, you're really good. All right. All right, folks, let's first remember how long division works with just plain old numbers, like this problem here. There's 4 basic steps. The first is division. You divide. So you say, how many times does 4 go into 5? 5 divided by 4 is 1. Then you multiply. 1 times 4 is 4. You write that underneath that 5. Important to keep these lined up nice. Then you subtract. 5 minus 4 is 1. Notice I'm not writing a minus sign there. I'm just going to always remember that we always subtract. Then we bring down the next digit. Bring that 1 down. And start the bring down. And then you start the process again. 4 divides into 11 2 whole times. Multiply. 2 times 4 is 8. Subtract, always subtract. I'm not writing the minus sign. If there was more to bring down, I would. This is my remainder. And what I would do with that is I'd make it into a fraction. I'd put the 3, or whatever the remainder is, on the top, and I'd put the 4, or whatever this is, on the bottom. Now we're going to use the same steps with long division of rational expressions. This is the example that's in your book on page 393, example number 3. Right here. And the book does a good job of explaining it. I'm going to show things slightly differently than the book. In the book, they write the 2x over this x here. I think you'd be happier putting it over this term. X fits into 2x squared. Well, let's see. X times what gives you this? We need the 2. 2 times x. Hey, we need another x. 2x times x is 2x squared. Instead of putting the 2x there, I would put it there. You don't have to do it my way, but I like it better. So that's step 1, division. Then you multiply. 2x times x. That's 2x squared. Those should always be the same. If they're different, you got to go back and fix it. 2x times positive 2 is positive 4x. That's the multiplying. Now it's time to subtract. Here's the next thing I do differently than the book. In the book, they put minus signs in here. They take this and they put a minus sign there and a minus sign there, and they change everything. Boy, those minus signs cause trouble. They wander away and get lost in the forest. Let's not do that. Let's just remember we're always subtracting. 2x squared minus 2x squared, those are the same. They cancel. They have to cancel every time. Negative 1, you know there's a 1 there. Negative 1 minus 4, that's negative 5. Negative 5x Are you keeping everything straight and lined up? And then you bring down. So you bring down the minus 10. Here we go again. How many times does x go into negative 5x? In other words, what up here, negative 5, times x gives you negative 5x. Oops. My mistake. Negative 5 times x is negative 5x. You multiply now. Negative 5 times x, negative 5x. Those have to be the same. Negative 5 times 2, negative 10. Now it's time to subtract. Always subtract. The book changes all these symbols. No, I don't want to do that. I'm going to remember to subtract. Negative 5 minus a negative. Minus a negative is like plus. That's going to cancel. It always does. And looky here, these ones cancel also. Negative 10 minus negative, that's plus again. It's always subtracting a negative. It's like plus. So those ones also cancel. Hey, there's no remainder. That is your final answer right there to this problem. 0 is important. It's taking up space. It's a placeholder to tell you that there's no 10s. Okay. In this problem, you're going to need zeros also. So we're going to take the 3x plus 2 and divide it into 27x to the third plus 9. But notice it skipped from x to the third all the way down to no x's at all. You need to fill in each of these spots with 0 x squared and then 0x. The exponent must count down by 1. X to the third, x to the second, x to the first, no more x's. Okay, here we go. Same 4 steps over and over. 3 times 9 is 27. The book would write it here, I'm writing it here. How many x's do we need? Well, we got 1. We need 3. I think we need 2 more. That's the division. Then you multiply. 9x squared times 3x. These always must be the same. If there's not, go back and fix it. 9 times 2, that's 18. 18x squared, okay. That's the multiplying. Now we're subtracting. I don't change all the signs. I just remember I'm always subtracting. 0 minus 18, that's negative 18. X squared, keep it neat and lined up. Bring down that 0x. The ox is a friend of Math Dog. Let's see here. 3x goes into negative. Oh, negative, careful. 3 times negative 6 is negative 18. I've got 1x. I need 2. I need another x. Notice in our answer, the exponents also count down. 2, 1. Pretty soon we're not going to have any x's at all. Okay. That's dividing. Now multiply. This times this always must equal that. If it doesn't, go find your mistake. Negative 6x times 2, that's negative 12x. All right. These are exactly the same. When we subtract, they cancel, as they should. Must. 0 minus a negative. Oh, that's plus. Minus a negative, you know that. But it's easy to forget. That's the thing I'm most worried about on these, the subtracting step. And then we bring down our 9. Let's see here. 3x goes into 12x. Well, let's see. 3 times 4 is 12, positive 4. And we don't need any more x's. Oh, just as I predicted. X squared, x, no x's at all. They're counting down. Time to multiply. 4 times 3x, 12x. 4 times 2, 8. Time to subtract. Always subtract. Cancel. 9 minus, where's the minus sign? I don't write it. I just remember I'm always subtracting. 9 minus 8 is 1. Hey, that's my remainder. What do I do with that? Well, if it's positive, I write plus. If it was negative, I'd write minus. I put the 1 on top, and I put the 3x plus 2 on the bottom. Done and done. Now, if you understood that one, good for you. There's examples in the book also, but again, these are the examples that you want to use when you're working on page 396, 11 to 18, and various other problems that look like this with division. Okay, nice work, folks. That was good fun. Now Math Dog and I are going to relax for a little while.
Hey, have you checked the mail yet?
I'll do it. Don't growl at me. I'm not the one who lost the test kits.